Alright, for my screencast, I'm going to be explaining a problem that we got for review in class. I'm going to read it out right now. A 5-kilogram monkey hangs initially at rest from two vines, A and B, as shown above. Each of the vines has a length 10 meters and negligible mass. Okay, so now I started out by drawing a force diagram, and as you can see, there are three main forces we focus on. The force exerted by the earth on the monkey, the force exerted by row B on vine B on monkey, and the force exerted by vine A on monkey. Okay, that's part A. And next, part B asks for the tension of vine B. So since we know that the monkey is at rest, we can obviously say that the F net is going to equal to 0. And if the net force is equal to 0, then we know that the net force along the x-axis is going to also be equal to 0. So we set both forces, the components of both forces, we set them equal to each other because we know that the net force is equal to 0. So we solve for the tension A, as you can see, and next we go to the net force in the y direction, and we can say that's 0 as well since the monkey's at rest. So next, we have a formula. Like we divide the force up into components. So we have sine 60 times TB plus sine 30 of TA is equal to mg. And now we can plug in our earlier value for TA into our second equation down here. And if we simplify, we can get that TB is equal to 42.44 newtons. So the tension of vine B is around 42 newtons. And next, part C asks us how fast the monkey would be going at the bottom of its swing if it let go of vine A. Alright, since we know over here, I just drew a little diagram of what's going to happen. The monkey's over here originally, and after it lets go, it'll be around at point P, I marked it. So if we can find the height change in here, we can find the kinetic energy that was gained by the monkey. Okay, so I calculated delta H using the initial height the final height minus the initial height that I had. And I got 1.34 meters. Next, using conservation of energy, I knew that the final kinetic energy would be equal to change in gravitational potential energy. So after some simplification, I got the velocity to be 5.1 meters per second. And next, we went on to part D, which asked us to find the tension in vine B as the monkey passes the lower point of its first swing. So we know that in circular motion, the formula force is equal to mv squared over r, the centripetal force, that is. And the force is also equal to TB minus mg. And we could just equate those two things. And if we simplify for TB, we get mv squared over r plus mg. And we just need to plug in our values, and we should get 62 newtons. And I think that's the entire problem. Thank you.